Welcome to yet another OmniFocus Fitness video. My intros are typically a little more excited than this, but as I'm stuck in my university library, I don't have the luxury of being extremely excited, but that does not take away from the subject matter, which is extremely exciting, and that is oxidative stress. We're going to be covering what oxidative stress is. We're going to be talking about the mechanisms that create oxidative stress. We're going to talk about free radicals, and we're going to talk about antioxidants. We're going to talk about everything as detailed as we possibly can without getting too detailed. So you'll know a good basis of information on all of these subjects by the end of the video. And there will be further videos and articles that will go into even greater detail on all of these. Okay, well, without further ado, let's go ahead and get started. Okay, so first of all, we should probably understand what oxidative stress is. What is the definition of oxidative stress? And again, usually I try to make things as simple as possible before I go into detail, but oxidative stress is having a proportionally high number of free radicals to healthy molecules. So the proportion of free radicals to healthy molecules has increased to a point that the body can't necessarily handle that proportionally higher amount of free radicals. That's all you need to know for now, and hopefully you'll understand the idea, the concept a little bit better once we get deeper into this video, or just by reading the article that I've got linked. Okay, so next up, if you aren't familiar with the term free radicals, you're going to have some serious issues understanding the rest of this video or understanding the linked article to this video. So let's go ahead and figure out what exactly free radicals are. For us to understand what free radicals are, however, we need to understand what molecules are. And for us to understand what molecules are, we have to understand what elements are. And for us to understand elements, we have to understand atoms. But don't worry, I'm going to make this pretty simple. So atoms are the smallest unit of measure for mass. So as far as the matter around us is made up of trillions and trillions of an insurmountable amount of atoms. And atoms are made up of three particular particles. We're only going to worry about one of those, however, which is a defining feature of an atom and a defining feature of elements and a defining feature of molecules by that stratification. So we are concerned with electrons. However, atoms are made up of protons, neutrons, and electrons. Protons and neutrons are isolated to the nucleus of an atom, while the electrons are orbiting that atom. Or in simplistic terms, that's the way I understand it, and that's the way most people understand it. Then moving on to elements, we have, if you think of the periodic table, I'm sure you've seen it ever since middle school. You probably were introduced to the periodic table, and you saw all these different elements. Well, all those elements are made up of, each individual element is made up of a particular number of a grouping of atoms with a particular number of electrons. So if you this isn't completely correct, but for the purpose of this video, we can understand that having electrons be the definition of an element. So the number of electrons that are on an atom all those atoms that have that particular configuration of electrons would then make up an element. An element like, hydrogen, for example, is a perfect example. Or, you could pick anything, uranium. Like there's all the elements that are located on the periodic table follow this rule. So then if we move up from element to molecule, which is where we'll understand what free radicals are, elements make up molecules. So molecules are basically just a configuration. It can be any number of configurations of different elements. So a perfect example of this is H2O, so water. You have two elements of hydrogen, right? And you have one element of oxygen. And that creates H2O, the molecule H2O. And what we're going to be focusing on in this video are the organic molecules, protein, carbohydrates, and fats. Those are the most prevalent in the human body, and those are going to be the ones that we're going to focus on. So how does that play in with free radicals? Well, a healthy molecule has a set number of electrons. So because those elements make up a molecule. So if you take H2O, for example, it has a certain number of electrons that render it stable. So that creates a stable molecule. A free radical is a molecule that is, for lack of better words, a unhealthy molecule. So an unstable molecule, because it lacks an electron. Electrons come in pairs. So an electron pair is exactly what the name implies, is two electrons in one grouping. So you have two electrons in one group, and then of course you can have several groups that make up more electrons that define a particular molecule or define a particular element. But free radicals, on the other hand, they have at least one of those groups is missing an electron. So it is a single electron, and that is extremely problematic. It's problematic because, as I've explained before, a healthy molecule has paired electrons. So what exactly happens? That's the most intriguing part. What happens when a molecule only has one electron in one of those groupings? Well, it goes frantic, basically. It becomes extremely reactive. And when it becomes really reactive, what that means is that it starts moving around and starts trying to take away electrons from surrounding molecules. So if you've got a bunch of normal healthy molecules and then you have a free radical, that free radical will gravitate towards one of those healthy molecules and try and take one of its electrons. And it's quite good at doing that, especially molecules that have a weaker bond. So it will take an electron and then pair it with its single electron that it already had. And when it does that, it becomes a stable molecule. But the issue is that then that molecule that the electron was taken from now has an unpaired electron, and because of that, it itself becomes a free radical and starts becoming, in a way, frantic and becomes highly reactive. And the cycle continues and continues, and that creates a good amount of damage. Now, for us to really understand exactly how all that works, let's go on to the next section where I'm going to break down how free radicals exactly start from the beginning and how they end and how destructive they can be. Okay, so now I'm going to take you step by step and exactly show you how exactly a free radical is born to begin with, as well as how it affects molecules. I briefly touched on it in the free radical portion, but I'd like to go more detail so you really have an understanding of exactly how it works, as well as how free radicals end. So they don't last forever. So their birth, what they do, and how they end in a more detailed fashion. But I can't really do that by just sitting here and talking about it. I think it helps with having visual aids, and that's why I have figured out through my extensive sarcasm editing skills that I can draw up a blackboard, so I will show you. So let's go ahead and do that. Okay, so let's check this out. What is the mechanism for free radical function? The mechanism is broken up into 3 different levels, so 3 different steps from birth to death, and those are called initiation, which is, in a manner of speaking, the birth. Then we have propagation, and we have termination, which makes a lot of sense. Most likely that will be the end of the free radical. So we're going to break down each one of these. They're pretty simple, not much to them, but I think that they're still important to fully understand how free radicals work. So let's look at the first step. Okay, so talking about initiation, the birth of the free radicals. Sounds like a movie, The Birth of the Free Radicals. Really cheesy movie. So we are in a situation now where we have healthy molecules. So we're going to represent these healthy molecules here. This green orb and this green orb are 2 healthy molecules which are bound, each one of them contributing 1 electron to this relatively weak bond. But they are in a happy, stable state. Now, free radicals don't just appear out of nowhere. They do need some sort of stimulus, and that stimulus can come from any number of stressors which are discussed in the video. In this case, we're just going to take one of those stressors, which is UV radiation, so the sun. The sun then contributes, wow, can't even draw arrows correctly, contributes stress, or in more technical terms, contributes heat and or light to healthy molecules, which then in turn makes these molecules move back and forth, kind of shiver in place, move back and forth. And as they move back and forth, eventually enough energy builds up so that this bond here is broken. So it breaks. Alright? So once that happens, we have the creation of, that's right, I drew it in red. Hopefully you can tell what this is supposed to be, but of free radicals. So we've got 2 separate molecules, each with 1 electron, so a non-paired electron, and which by definition is a free radical, or if you want to simplify it, just a radical. Both roughly the same thing. So that is the birth of free radicals. So now we're going to see in the next step what exactly happens from then on. Alrighty, now we are in the next step called propagation. Propagation is basically how free radicals then interact with other molecules, so usually healthy molecules. And this diagram, this extremely simplistic diagram, indicates just that. So over here we've got green, again supposed to symbolize healthy molecules. You have these individual molecules, and they can have, of course, more than just these 2 electrons, but for the sake of simplicity, they're filled with electron pairs. So I just drew one pair, but it can be many more. So they're filled with electron pairs, and they're nice and happy and stable and doing all kinds of different functions for the body. And then our previous molecule has now split into two molecules of free radicals. So, and they are right here. So these two red molecules. So as you can see, they only have one electron, which is again the definition of a free radical or a radical. And what they're going to do is then gravitate towards these healthy molecules. And once they bounce into these healthy molecules, then each of these healthy molecules gets ransacked and pillaged and loses an electron, as the electron is then attached to the previous free radical. So I redrew this so that you could get a little bit clearer of an image. So free radicals move towards the healthy molecules. Healthy molecules then have to give up, as signified by this purple arrow, a electron. So let's go ahead and do that. So the healthy molecule loses an electron, and the free radical then gains an electron. Now let's go ahead and change the color. Then this turns green because these become stable molecules. And what, of course, as logic would dictate, happens to these? Oh god, I can't draw circles. Oh, my shortcomings are coming through. These become free radicals. So then if we move that back over here, after the exchange of electrons has happened, this becomes red, and this would of course become green. And this constant damage happens because this happens, of course, and then what happens is that these free radicals are then going to probably, in a manner of speaking, infect some other healthy molecules, and it just keeps happening over and over and over again till all the healthy molecules have been attacked or had an electron ripped away from them, and to satisfy a free radical. Excuse me. Alright, so finally we're at the last step, which is called termination. Termination. Kind of like the Terminator. Actually, it has nothing to do with the Terminator, but I just felt like doing it. So we are at termination, which is the kind of the end portion of this whole mechanism. And I've drawn here several different free radicals and just one healthy molecule, because in this instance, most likely, well, let's first determine what termination is. Termination is just when free radicals run into each other and then neutralize each other. However, this happens extremely rarely, especially at the beginning of a free radical cycle. So when you have oxidative stress and it's just starting, you have fewer free radicals, so it's more likely that it's going to end up interacting with healthy molecules. But as it goes on and on and on, as we know, because it's a chain reaction, as that chain reaction goes unstopped, then eventually you end up with many different free radicals, and eventually you have a proportionally high amount of free radicals and you have high oxidative stress. And because of that, it is possible, it's more possible, that free radicals can run into each other and then neutralize each other. So you have many free radicals and fewer healthy molecules, and because of that, these free radicals will then interact with each other to neutralize one another. But by that time, that's not necessarily good news, because by that time, if you have that much oxidative stress that this could actually occur, most likely you're in pretty deep trouble, because that area is more dysfunctional than it is functional. So that's that. That's all you really need to know about termination. There isn't too much more related to that. This is all based on if free radicals are given free rein to do what they will without several of the mechanisms, for example, like free antioxidants, that would then help stop free radicals before we got to a high oxidative stress situation. So, now that you understand in far more detail what free radicals are and how they affect the body, let's discuss a few of the things that actually cause free radical damage, or free radicals to form. From a macro perspective, so what are you doing that's causing more free radicals to appear in your body? Well, really any stressor of any sort is going to create more free radicals. So we're talking about like inhaling pollution, for example, smoking, drinking alcohol, I would say probably just general stress, as well as, you might find this surprising, but exercise. Exercise is technically a stress on the body. So you're probably thinking, okay, well, so have I been lied to? Is exercise somehow hurting me? Well, yes and no. When we're talking about exercise, we're talking about exercise creates stress by, breaking down muscle, creating micro tears, things like that. And when we create micro tears, of course, we're creating damage. And that damage can produce free radicals, but that does not necessarily mean that exercise is bad for you, because apparently what the body does is then enhances its ability to clear free radicals. So it enhances its ability to then get rid of free radicals. So although the production of free radicals increases, and we know this not because we've been able to measure free radicals directly, but because we've been able to measure free radical byproducts. So because of that, and the research is still pretty new on this, but apparently free radical amount increases, but the shuttling and the neutralization of free radicals also increases. Now this is only really true of moderate exercise. And what I mean by that is if you ease into a workout program, or you ease into any sort of exercise program, and you allow your body to adapt to that program, then your body is able to shuttle free radicals and adapt to that free radical accumulation. However, and this goes against people who just go ham, like they just throw themselves in the gym and they just start beating the crap. They go in the gym for like 2-3 hours and just destroy themselves. In that case, it shows, the preliminary research seems to show that there's a massive spike in free radicals. So you're proportional to normal levels. So you have an increase in free radical amount, but your body hasn't been given enough time or the resources to then deal with those free radicals. So it is possible that at least on an acute level, I'm not saying that you're necessarily just going to die just because you throw yourself in the gym and go nuts, but you'll have an increase in at least an acute amount of free radical production, and your body doesn't have the mechanisms or enough of the mechanisms to then shuttle those free radicals or neutralize those free radicals. Also, other areas like radiation, of course, wear sunscreen, UV rays, things like that from the sun will definitely increase your free radical damage, and that can actually be seen on your skin, or at least that's the prevailing theory, is that the wrinkling in your skin is caused by free radical damage. as well as aging. So our major theory on why we age is actually based around free radicals. I'm not going to go too much into detail with that right now, but the more as we grow older, create more and more free radicals, which then eventually cause prolonged damage on that healthy tissue made up of healthy molecules. So that's something, as well as our metabolism actually creates free radicals as a byproduct as well. So that could tie in to the whole aging process as well. And then finally, a poor diet. People say you should eat your greens, right? Well, you should be eating vegetables, you should be eating fruits. And that makes a lot of sense from a free radical standpoint. Most people just say, okay, well, it's good for you. You know, eating your greens is good for you. Well, most people don't really understand why. There's a lot of those vitamins and minerals that are found in your vegetables that actually help combat free radical damage. So in a way, it's the anti-agent of free radical damage. It's a way to slow down your aging by eating a well-balanced diet. So while those other factors actually cause free radical production, a poor diet or a one-sided diet that steers away from eating vegetables and fruits on a consistent basis is actually limiting your ability to fight free radicals. So that's that. Those are a few, and of course, like I said, there are tons and tons of stressors out there. So that's just a few that I thought were really interesting, and I thought you might enjoy. Okay, so you know what causes free radicals, you understand what free radicals do, their mechanisms, things like that. You understand the overarching theme of oxidative stress, and you'll understand that theme a little bit more in a little bit. But what can you do against free radicals? That might be important, right? You don't want to just educate yourself on all the bad things. You also want to educate yourself on how you can help. Well, in the previous section, I mentioned that exercise could lead to an acute increase in free radical damage. And that is true, but moderate exercise, so taking things slowly and slowly allowing your body to recover the appropriate amount, can actually enhance your body's ability to fight free radicals. So moderate exercise would be beneficial in the long run for fighting free radical damage. That is not to say extremely intense exercise, because really intense exercise and not enough rest duration will actually increase your free radical amount. So moderate exercise, that's one way. The second way is nutrition. And I've already touched on this a little bit in the last section talking about poor diet, but eating, making sure that you eat vegetables, fruits, getting a wide variety of different foods, eating a balanced diet will actually increase your body's ability to then fight free radical damage. And we're going to go into that with more detail into the next section. So exercise and nutrition, well-balanced diet, as well as exercise. Moving on. I barely touched on this earlier, but as a huge proponent of nutrition are antioxidants. Now, antioxidants, let's break down that word, antioxidant. So oxidation is, in chemical terms, so if you were to ask a chemist, oxidation is giving up an electron. And as we discussed earlier, free radicals take an electron. So that molecule that is then giving up an electron, that is an unhealthy state, because it's giving up an electron to a free radical and then becoming a free radical itself. So antioxidants are the anti-oxidation of a healthy molecule. So what antioxidants do is that they're molecules themselves, and they actually specifically battle with free radicals. So while a free radical is buzzing around trying to take an electron from something, an antioxidant can come in, and that molecule, because it's specifically designed for a free radical, will then give up its electron without turning itself into a harmful free radical. So that way both molecules become neutral, and that way you are able to then mitigate the damage. Now, that is not to say that a person should just focus on one antioxidant, because there are many antioxidants out there that we know of, and I'm sure there are many more that we'll discover later on down the road, because we do need quite a bit more research on this in this area. But if you were to eat a well-balanced diet, some of the main antioxidants that we're talking about are like vitamin A, vitamin E, vitamin C, manganese, tons of different minerals, along with other vitamins, are extremely important for minimizing free radical damage. Last thing I want to mention on antioxidants is, before you go crazy and just start buying a ton of vitamin E or vitamin A or a combination of everything, you should know that there is some research out there that actually says that if you overconsume on antioxidants, you can actually create damage to your body. So you're not in a superior healthy state just because you consume antioxidants. So we understand much more about free radicals, but we don't really know yet, as far as visibly, how can we know that free radicals are doing so much damage? Well, at least partially, if not fully, some of the major diseases that we talk about are actually caused, again, at least partly by oxidative stress, so by free radical amounts. And some of those, I'm sure almost everyone is familiar with, are like certain cancers, if not all cancers. We're talking about like Alzheimer's disease, things like, I did mention earlier that the major theory of aging comes from oxidative stress, so free radical production. So those are just a few of the major things that we've attributed to free radical damage. I'm going to also kind of explain how free radicals have an impact on cells, so how they specifically damage cells, and even worse yet, DNA right now. Okay, so now we are going to go ahead and see exactly how free radicals would affect not just an isolated molecule or a few molecules just floating around, but actually impact a structure. And in my article I discuss the cell membrane, so I thought it might be a good idea to go ahead and try and explain how free radicals might affect the cell membrane. So as you know, my artistic abilities are quite shitty, but this green thing here is supposed to be a cell membrane. So I'm going to go ahead and label it as such. So this thing, cell membrane, and it will do its job as far as illustration abilities are concerned. So we have the outside of the cell, and we have the inside of the cell, pretty self-explanatory. And the cell membrane keeps things that are supposed to be outside, and keeps things that are supposed to be inside, and allows things to move back and forth in limited amounts based on how the cell needs it. So it's extremely important. Now, the cell membrane is, of course, made of many molecules, specifically fat molecules and a little bit of protein for those channels, which I have not shown here for simplicity's sake, but just know that a piece of the cell membrane, this is just a piece of the cell membrane, and all these green pieces here are made up of molecules. So each circle is a molecule. Of course, this is a extremely rudimentary explanation, but that it should do for our purposes. So we have a completely healthy environment right here, and we have no free radicals, which will be represented by red circles. So what we're going to do is take a look at just a small piece of this piece of cell membrane, and it will be detailed in this blue box. And if we zoom in on this blue box here, what we will end up is right here. So zoomed in, sort of. So we're zoomed in on a small piece of the cell membrane. Then if we zoom in even further and we look at this purple box, we zoom in over here and we find ourselves with one healthy molecule and one unhealthy molecule, or a free radical. So this healthy molecule has stable bonds, has stable paired electrons, and the free radical has one unpaired electron. Now these E's are supposed to represent elements. I didn't feel like adding different elements because I thought that would be confusing. The E's are supposed to represent elements because, as we know, different elements make up, different configurations of elements make up molecules. So these elements E2 and E2 are the same. E1 is obviously different from element 2. This could be, you could put in carbon, nitrogen, hydrogen. I mean, it could be any of the elements that are located on the periodic table. So as we know, free radical with is highly reactive, is going to bump into this healthy molecule, and then is going to steal an electron. By doing so, it's going to break this bond. So this bond is broken, and this element actually moves over here as it's stolen from, in a manner of speaking, it is stolen from the healthy molecule. So E1 gets added here, and we end up with a happy bond. So we have a happy bond for the free radical. However, in this case, the previously healthy molecule now only has one electron and now becomes a free radical. So let's circle this in red so we can get an appropriate color for it. Okay, so I kind of cleaned things up, but it's the exact same setup. So we've got our new free radical here, and our old free radical here, which is now a stable molecule. But the reason why I painted it in orange and not in green is because green was an E2, E2, and E1. So all these green molecules are E2, E2, E1, and this free radical was just E2 and E3. So an element 2 and element 3, and then added element 1. So this is not the same structure as it was, nor is this the same structure that it was. So this is not only a free radical, but also a different structure than the other healthy molecules that it used to belong to. And that is the trickiest part. That's the real premise of this entire section, is that when a free radical is fixed, so let's say it takes an electron and it takes an element, because when it takes an element, it's changing its structure. So it might become a completely different molecule, and although it's not highly reactive anymore, the issue with that is that it might not be a very useful molecule. So all these molecules over here, and the same thing is true for all these molecules over here, they're all the same structure, just assuming for this example, they're all the same structure, and they all have the same structure because they have a specific purpose. So again, for a cell membrane, most likely these are like lipid molecules, because the lipid bilayers make up the cell membrane. So if we start changing these, so let's take this diagram and extrapolate that here, what happens is that this red one becomes orange, right? Because it's stable, but it's not the same molecule as it once was. And this one becomes red as it becomes a free radical. And you can imagine that this one is probably going to end up ripping an electron from a neighbor, right? And as it's taking an electron from a neighbor, if we focus in on this view again, this is going to turn orange. This means that it's going to be, again, a stable molecule, but not necessarily a molecule that is still able to fulfill its function that it originally was fulfilling this whole time. And when it does that, of course, it's going to, let's say, take an electron from that. And then this one is going to eventually take an electron from another molecule, and so on and so forth, till eventually, if we then move up, right? Okay, so let's go ahead and illustrate some of that. We've got our radical that's been, our initial radical that's been satisfied. We have, and then let's say it goes on and on like that. So the next one becomes a radical, then it becomes stable, but then the molecular structure isn't the same, and it keeps going and going and going until, because this is all based on a chain reaction, and eventually all these different molecules are going to change to kind of, in a manner of speaking, as you could call them, inert molecules. And that is actually going to create some massive problems for the cell, because then what happens is you have areas of a cell membrane that suddenly don't work as well as they used to. They don't hold stuff in as much, so you've got stuff diffusing out, you've got stuff moving in, and then eventually the issues get so problematic that the cell ends up dying, or another cell, some sort of immune cell, will then envelop this cell and take care of it, kill it. But that's not what this video is about. Anyway, so this can affect, the cell membrane we're talking about. I mean, this kind of stuff can also affect DNA, which is extremely dangerous, because anything could happen if you're going to affect DNA. You could have certain mutations which could lead to cancers, could lead to degenerative diseases like Alzheimer's, things like that, and the list goes on and on. So that's how all of this stuff works, and how it's going to affect, in this example, cells on a micro level. Okay, so kind of a curious question, but can free radicals resolve themselves? And the answer is quite clearly yes, they can. If we take what we already know about free radicals, and knowing that free radicals bounce around till they can find an electron to then take away from a healthy molecule, all they want to do is get an electron. That's what they want. That's their end goal, and that's what makes them extremely reactive. So, is it then possible for free radicals to then collide with one another in such a way that they then share an electron with each other, so making that electron pair? So if one free radical has one electron and another free radical has one electron, and they combine together, they can technically share those electrons and make a electron pair. To understand this mechanism, we have to go back to oxidative stress. So remember how oxidative stress was a proportionally high number of free radicals in the body? Well, the higher the amount of oxidative stress, the more likely it is that free radicals will resolve themselves by bumping into each other and neutralizing themselves. However, by the time that happens, you would have to have a major amount of oxidative stress, so a massive amount of free radical damage, for there to be many more free radicals than there are healthy molecules. And by that time, it's kind of a moot point. But I thought I'd add it in just because I thought it was kind of a cool concept, knowing that free radicals aren't specifically after just healthy tissue or healthy molecules that make up healthy tissue, but can also resolve themselves. Finally, I wanted to add a small section on, can free radicals be a good thing? Everything that I've detailed so far has been pretty morbid, considering that oxidative stress, which comes from a heightened amount of free radicals, is pretty terrible. It causes all kinds of diseases and really does tons of damage to the cells, as well as really any sort of organic matter. So, can free radicals be used for a good thing? And the answer is, again, yes, absolutely. The cells, surprisingly, actually use free radicals. The body creates free radicals, and sometimes through mechanisms that I'm not going to discuss in this video, but I will discuss in future videos, the cells actually create free radicals to then be used against, for example, like bacteria, viruses, things like that. You know that free radicals by now create a lot of stress and do a lot of damage and are pretty uncontrollable. But if the cells then engulf, for example, a bacterium or a virus, the cells can then produce free radicals to then and have them around the bacterium to then, put tons of stress on that bacteria and then hopefully eventually kill it. So the answer is yes. Free radicals can be used for a good thing. They often aren't. Most of the time they are not, but they can be. Okay, so this is a rather extensive subject, but I like to add summaries for those people who don't want to go through these 30, 40, 50-minute videos that I sometimes have a knack of making. So a quick summary is oxidative stress is having an elevated amount of free radicals, so much so that the body actually has a lot of damage that's done to it. And free radicals are basically just unhealthy molecules that are highly reactive, and they create chain reactions. And those chain reactions actually do damage to surrounding molecules that may have been previously healthy molecules. And it does this by taking away an electron from a healthy molecule, which then makes that healthy molecule kind of like, if you think of like a zombie apocalypse, it bites the healthy molecule, and the healthy molecule becomes highly reactive itself as it tries to find an electron to take from another molecule and another molecule, and the cycle just continues like that. Free radicals are caused by, in general, stressors. So we're talking about aging, radiation, so sunlight, or immense amount of sunlight without sunscreen. That's why you should wear your sunscreen, or at least one of the reasons. Poor diet causes free radicals to not get neutralized as easily, and free radicals do damage in a visible manner, as can be seen in most cancers, Alzheimer. As I've mentioned, aging, the main theory of aging that we have comes from free radical damage. And what can you do against free radicals? Well, you can first put yourself on a moderate exercise plan, because that allows the body to adapt and become better at shuttling or neutralizing free radicals. Then on another note, having a good balanced nutrition will increase the amount of antioxidants that you have in your system. And antioxidants are a type of molecule. There are many different antioxidants, but they're a type of molecule that neutralize free radicals without turning into free radicals themselves. So they allow healthy molecules to remain healthy while taking care of those free radicals that would be otherwise highly reactive. there are many different types of antioxidants, like I mentioned, but some of the main ones are vitamin A, vitamin C, vitamin E, manganese, as well as tons of other minerals and vitamins. However, you should not overconsume antioxidants, because the research right now shows that antioxidants in a overconsumed state can actually induce health problems in their own right. So just eating them at the recommended amount is probably good enough for you. And that's it for now. If you enjoyed the video, then please feel free to subscribe. The more subscriptions I have, the more motivated I am to continuously come out with this content. And if you aren't familiar with my format by now, you should know that I have a far more detailed article on this subject. So first I write an article, and then with all my sources listed, which will be linked below, or as the screen fades out, I like to put it on top of the video. So you're going to see in the top right corner, in your top right corner, you're going to see a little mark with an eye, like a circle, a white circle with an eye in it. And it's going to pop out and it's going to say click for the article or something like that. If you click on that, it'll lead you to the article, and you can check all my sources as well as look at far more illustrations and be able to check up for yourself, because I do encourage people to think critically. Okay, well, hopefully the next video I'll be able to be a little bit more expressive. I got completely drenched on my way to the library because it was pouring, but I promised myself that I would release this video because I've been working very hard on the article. So, without further ado, I shall see you in the next video. Hope you have a good day. Hey, thanks for watching. If you'd like to know more details or look at my sources, check out OmnifocusFitness.com, link below. There I cover everything in greater detail and fidelity. I'm a one-man operation dedicated to educating myself and others through scientific study. As such, I'd really appreciate it if you subscribed, liked, and shared the video to spread the knowledge. Content will remain free. Cheers, and see you in the next one.